In this video, we're going to answer questions 80 through 83. So, 80 through 83 is going to deal with how we organize data and how we look at it in terms of its picture. Now, 80 says the histogram shown below represents the number of televisions per household. So this is based on a sample of U.S. households. Basically, it says how many households are included in the histogram. That's the question that is being asked. How many households are included in this histogram? So we can do that by finding the frequency for each of the number of TVs. 20 people have one TV in their household. 50 people have two TVs in their household. 15 have three TVs in their household. 10 people has 4 TVs in their household. And 5 people has 5. Give me a second. Let's look at the units. Per household. Well, 5 people have 5 TVs in their household. How many households are included in this histogram? We can just add up those numbers. So 20 plus 50 plus 15 plus 10 plus 5, that equals to 100 households. And that is our answer for question number 80. Okay, number 81. It says prepare a frequency distribution with columns and intervals prepare a frequency distribution with a column for intervals and frequencies. Use 5 intervals starting with the interval from 0 to 4. Okay. So let's draw our table. You know, we can draw it over here. We can draw it right over here. That would be great. That's going to be question 81. And then we have our class. So we're going to have our classes. And then we have our frequencies. And it says start with 0 through 4, which means the next class has to start at 5, and it's going to end at 9. And the reason why I know it's going from 5 to 9 is because of the following rules. If the first class is 0 through 4, the class limits cannot overlap. So the next class has to start at the next unit, the next whole number. The distance between 0 and 5 is 5 units, which means every limit has to be 5 units apart as well on both the lower limit and the upper limit. So then we have the next going to be 10 to 14, 15 to 19, 20 to 24. Each of the upper limits and lower limits are 5 units away from each other. Hence, the width is uniformed. So let me reconstruct this. 5 to 9. And now we have to be careful how we count. How many data values are in the first class of 0 to 4? 1, 2, I believe that's 2. So that's the frequency is going to be 2. Then for the class of 5 to 9, that's 1, that's 2, that's 3, that's 4, that's 4 values. So the frequency of that is 4. Then we have from 10 to 14, so that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. The class from 15 to 19, that's 1, that's 2, that's 3. There are 3 of those. And then the class from 20 to 24, 1, 2, 3, 4. So let's make sure everything is correct. Let's count how many pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But here this doesn't add up to 20, so that means I have to double check. Ah, man. I think I missed a 15 somewhere. So between 0 to 4, that's 1, That's 2. Okay, that's correct. Between 5 to 9, that's 1, that's 2, that's 3, that's 4. Okay, that's correct. 10 to 14, 1, 2, 3, 4, 5, 6. That works. 15 to 19, 1, 2, 3, 4. So that's actually 4. So we're going to replace that with the number 4. And the last set is also 4. That is correct. All right, so 82. It says the scores on a recent statistics test is given in the frequency distribution below. Construct the corresponding relative frequency distribution. Round the relative frequencies to the nearest hundredths of a percent if necessary. So basically, we're going to turn those probabilities into percentages in the end. So let's create our relative frequency distribution. So I'm going to draw a new table over here. We have scores, and we're going to have our relative frequency. So our classes is 0 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. And let's smooth out some of the kinks. So before we get started, let's just find the total of the frequency. So that's 15 plus 8 is 23, plus 6 is 29, plus 2 is 31. So the sum of the frequency is 31. To find the relative frequency, we're going to divide each of the class frequencies by the total frequency. So I'm going to write the formula down here to find the relative frequency. That is going to be the class frequency divided by the total frequency, or the sample size, if you want to call it the sample size. So for the first one, that is going to be 5 divided by 31, 10 divided by 31, 8 divided by 31, 6 divided by 31, and 2 divided by 31. And in our case, it wants us to have it as a percentage. So remember, to turn a decimal into a percent, you multiply the decimal by 100. So I'll write it here. So from decimal to percent, multiply by 100. So let's start finding those relative frequencies. So that's going to be 5 divided by 31. Then we could times that by 100. And that is going to be, when we round, 16.13%. That 9 next to the 2 makes that 2 round up to a 3. So that's going to be 10 divided by 31. And I'll just multiply it by 100 right away because we're turning it into a percentage. That is going to be 32.26%. That 8 makes that 5 round up to a 6. Eight divided by 31 times 100. And I'm going to do the next one since I'm already here. 6, well, let me delete that. 6 divided by 31 times 100. And I guess I'll do the last one, which is 2 divided by 31 times 100. And then we have the rest of our relative frequencies. So that's going to be 25.81%. Then we have 19.35%. And last but not least, we have 6.45%. And there we go. That is the relative frequency distribution. Okay, number 83. It says use the data to create a stem and leaf plot. So we can go ahead and definitely do that. So I am going to draw a line where the left side of my line, that's going to be where my tens are going to go, my tens place. That's the stem. On the right side, we call those the leaves. And those are going to be for our ones place. Okay, so let's identify the smallest number in the data set. That smallest number appears to be 63. It's a little more skinnier. Don't need it so thick. 63, so I'm gonna highlight it. I just want to double check just to make sure. No, I lied. The smallest number in the data set is 59. So 59 has 5 tens and 9 ones. So that's 59. Then after that, I'm going to look for the next smallest number. So I'm going to look at my 60s. We have 65, 68, 63. So for 63, that is 6 tens and 3 ones. For 65, that is 6 tens and 5 ones. And then for 68, that is 6 tens and 8 ones. And then we repeat the process. So now looking at my 70s, I have 77, 74, 74 again, 72, and 79. The smallest one is 72. So that's 7 tens and 2 ones. Then we have 2 74s. So that's 7 tens and 4 ones. You're going to write it twice because of having the 2 74s. Then we're going to continue this process. So then it's going to be 77 and 79. Then for our 80s, and I'll just put the 90s as well because we see 80s and 90s. We have 85, 88, 83, 85. So that's going to be 83 first, 285 second, and then an 88 last. Write that 5 better for you guys. So that is gone. And then for our 90s, we have 91, 93, and 97. So I want to double check to make sure that all of this is correct. There are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers in our data set. So we should have 16 leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oops, I didn't mean to erase that. This is our stem and leaf plot. All right, so that's it for this video. The main goal of this video was just to analyze data and to organize our data. And now in the next video, we're going to be finding some mean, median, and modes of single data and group data. Catch you in the next one.